In this session, I'm going to talk about factoring difference of two squares. Look at this. Flower to the power 2 minus leaf to the power 2. If you see any numbers like this, right? And then in this pattern, you can write as flower negative leaf and flower positive leaf. This is the answer. So look at this. A squared minus b squared. So if I want to factor, so I can write a negative b and a positive b. This is the answer. Okay, so look at this example. N squared negative 25. And here n squared, the first term is n squared. And 25 I can represent as 5 to the power 2, right? This is the perfect square of 25. So 5 to the power 2. Now I can write as n negative 5 and positive 5. This is the answer, right? Let me show you another example. 81 x to the power 4 negative 4. So 81 is, I can write as 9 times 9, 9 to the power 2. And x to the power 4, I can write as x to the power 2, right? And then 2 here. So 2 times 2 is 4. So x to the power 4, I can write as x to the power 2 raised to the power 2. So 2 times 2 is 4. So this full term, I can replace like this. 9x to the power 2 and raised to the power 2. So 9 squared is 81 and x to the power 2 and raised to the power 2 is x to the power 4. And 4 I can represent as 2 to the power 2. Now look at this. A squared minus b squared, right? So I can see the pattern and then I can write this one as n squared, nx squared minus 2 and nx squared positive 2. Right. Look at this example. X squared and 144. Right. So look at this. I can write down x to the power 2 and 144 I can represent as a perfect square of 12 to the power 2. Would I be able to do that? Would I be able to factor this? No, because why? This is positive sign. We are talking about differentiations, right? So the difference of two factors, two squares. So here is positive, not negative. Therefore, we can't factor this question sum. So this is wrong. So we can't factor. So the final answer would be x squared positive 144. We can't factor this, right? And let me show you another example. 98 a to the power 2 minus 50 b to the power 2. 98, would I be able to represent as a perfect square? No. 50? No. So, but 98 and 50, I can find the greatest common factor. What is the greatest common factor? 98 and 50 is 2, right? 2 is common for both of them. So when I take out 2, here remaining 49, a to the power 2, negative 25, right? b to the power 2. Now 49, now I can represent as 7 to the power 2, a to the power 2, negative 25 I can represent as 5 to the power 2 and b to the power 2. So I use now square bracket here, 7a raised to the power 2 negative 5b raised to the power 2, right? And then here again, I can factor this a squared minus b squared. So 7a negative 5b and 7a positive 5b. This is the final answer, right? Let me show you another example. X plus 5 to the power 2 negative y to the power 2. So here a squared minus b squared. Similarly, you can write as x plus 5 negative y and x plus 5 positive y. So this is the final answer. I hope that you understood this lesson. So we can continue from the next one. Thank you.